Good morning. Today's video, I'm going to perform my laboratory exercise number 2, which is kinetics and chemical equilibrium. Objectives. At the end of this exercise, you are expected to make and record observation, measurements, and approximations, interpret and evaluate experimental observations and data. General direction. Study the two experiment. Study the two experimental setups. Answer what is asked appropriately. Number 1. Identical pieces of brass were placed in two different boiling liquids for 12 hours. The graph shows the mass of each piece of brass change. Graph A is brass in boiling acid solution. Graph B, brass in boiling basic solution. Give one similarity in the change in mass of the brass in both liquids. By looking by looking at the graph, both brass on boiling liquid change in mass by time. Describe two ways in which the loss of mass shown in graph A is different from that shown in graph B. As you can see, wait a minute. As you can see, on the graph A, the mass loss continues to increase during the 12-hour period given, and there is a high chance that it will increase or it will continue if the amount of acid is kept in constant amount as the time continues to run. In graph B, the mass loss curve at 0.18 milligram sometime in 8 hours and maintain net mass loss amount per milligram until it reaches the time given of 12 hours. List three different safety precautions that are needed in doing this investigation. Um, Need to wear gloves, goggles, and lab coat. The rate of reaction between hydrochloric acid and aqueous sodium thiosulfate was investigated. When these chemicals react, they form a precipitate which makes the solution go cloudy. The formation of this precipitate can be used to show how fast the reaction continues. Test 1. Using a graduated cylinder, 60 cubic centimeter 60 cubic centimeter of aqueous sodium thiosulfate was poured into a conical flask. The conical flask was placed on a printed sheet of paper. 10 cubic centimeter of hydrochloric acid was added to the solution in the conical flask, and the stop clock started. The time taken for the printed words to disappear from view was measured. And on this, I have recorded 45 seconds. Test 2. Using a graduated cylinder, 50 cubic centimeter of aqueous sodium thiosulfate was poured into a conical flask, followed by 10 cubic centimeter of distilled water. The conical flask was placed on the printed sheet. 10 cubic centimeter of hydrochloric acid was added to the solution in the conical flask, and the stop clock started. Time taken for the printed words to disappear from view was measured 55 seconds. Test 3. Test 2 was replicated using 45 cubic centimeter of aqueous sodium thiosulfate and 25 cubic centimeter of distilled water. The time taken for the printed words to disappear from view was measured 65 seconds. Test 4. Test 2 was replicated using 35 cubic centimeter of aqueous sodium disulfate and 15 cubic centimeter of distilled water. The time taken for the printed words to disappear from view was 45 seconds. Test 5. Test 2 was replicated using 10 cubic centimeter of aqueous sodium thiosulfate and 20 cubic centimeter of distilled water. The time taken for the printed words to disappear from view was measured 145 seconds. Page 5 of 7. A used the stop clock diagrams to record the times in the table. Complete the table. Here is mine. Test for test 1, volume of aqueous sodium disulfate, 60 cubic centimeter. Volume of distilled water is 10 cubic centimeter. Test 2, 50 cubic centimeter. What volume of distilled water is 10 cubic centimeter. Time of printed words to disappear is 55 seconds. Test 3. Volume of aqueous sodium thiosulfate is 45 cubic centimeter. Volume of distilled water is 25 cubic centimeter. Time for printed words to disappear is 65 seconds. Test 4. Volume of aqueous sodium thiosulfate is 35 cubic centimeter. Volume of distilled water is 15 cubic centimeter. Time for printed words to disappear is 78 seconds. Test 5. Volume of aqueous sodium thiosulfate is 10 cubic centimeter. Volume of distilled water is 20 cubic centimeter. Time for printed words to disappear is 140 seconds. Page 6 of 7. Plot the result on the grid and draw a smooth line graph. So here is my graph. Test 1, 45 seconds of printed words to disappear. Second one, test 2, 50 seconds of words to disappear. Test 3 is 65. Test 4 is 78 seconds. And test 5 is 140 seconds. Page 7 of 7. See from your graph, infer the time for the printed words to disappear if the test 2 was repeated using 15 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water. I got 125 I've got 125 seconds of printed I get 125 seconds for printed words to disappear from the 15 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water. D. In which test was the rate of reaction greatest? Explain why the rate of reaction was greatest in this test. Test 1 has the greatest rate of reaction because as we increase the volume of aqueous sodium thiosulfate, the time for printed words to disappear decreases. Therefore, the greater the volume of aqueous sodium thiosulfate, the faster reaction it creates. That's all. Thank you for watching.